Hi, welcome back. Hope you are doing well, enjoying your life. So, in our earlier videos, earlier modules, module one and module two, we discussed about materials, raw materials, and the processes used worldwide for the production of PET. So, in this module, we are going to discuss about some of the new technologies which are used for the production of PET. So as in earlier videos, I just told you that the temperature of the process must be higher than 200 degrees Celsius, but in this module we will discuss about the temperatures which are used in different technologies. In all over the world, engineers and industries are focusing on a point to increase the production capacity and consequently lower the capital cost or production cost. So for this the invention and discovery of different technologies are done. Typically, there was a production of 240 tons of unsaturated polyester resin per day. But China is advancing in the technology. China is inventing new technologies for the production, and in last 6 years, China has invented such technologies that he can produce 600 tons of PET in one day. So, there are several technologies. We are going to discuss about the top of 5 technologies which can give us a very good production, above 300 tons per day of production with a lower capital cost. And the calculations of the costing and cost estimation is a larger field, and it will take much time, but as compared to other costings, their cost is less. Now in China, which is a master of the commercial market, China is producing much polyester resins, unsaturated polyester resins. But the two main industries in China which are producing about a range of 250 to 300 tons of PET per day, there are Zimmer AG and Mitsubishi Chemtex. They are producing approximately 250 to 300 tons of PET or unsaturated polyester resins per day. Now, one point to be noticed here: what is difference between process and technology? A process might have different raw materials, like in our case DMT and PTA process. We have different raw materials in both of our processes, but in technologies we have same raw materials. We will select one process and we will apply different technologies. The best process is PTA process and the most commonly used in all over the world. And now we will apply different technologies on it. Now, why we apply different technologies? We apply different technologies. Different technologies, we change temperatures, we change raw materials, we change the way of the production, we change different parameters so that we can get the same amount of product or a larger amount of product with less cost and make the process economical. So to make the processes economical, we choose different technologies. I will discuss 3 of the technologies in some details about their temperatures, about their raw materials in that technologies which are used, and all the parameters which are necessary for to know about a technology. So now talking about our technologies, so one of the most popular technologies for the PET production is a Chinese-based technology known as Hitachi's continuous PET process. In this technology, we will have to maintain a temperature of 285 degrees Celsius along with the pressure of 1 atm, and as a result, we will get our product, unsaturated polyester resin, and a byproduct of water and oligomers. As we know that in this world, no reaction is 100% efficient. Not all the reactants are converted into the products. All the reactions have their conversion rate of reactions. So in our case, we have a 90% of conversion. So there will be some byproducts, which is water and oligomers. Oligomers are those which will not get combined and will not form polymers. Some of the oligomers will remain unreacted, they will not combine with each other to form chains. Some of that oligomers will be achieved as a byproduct at the end of the reaction. So what we have to do with these oligomers? We will recycle them. We will forward them into other reactors more reactors so that these oligomers get more time and they combine with each other to form more polymers for us. So for this technology, the suggested number of reactors are 5. We have to use 5 reactors. So now what type of reactors we have to use? In this case, we will use CSTR reactors, stirred tank reactors, or we can say continuous stirred tank reactors. And the reason why we will use, I will tell you about this after the discussion on all the technologies. Now, our second technology, which is also one of the most popular technologies, known as Uday Inventa Fisher MTR technology. In this technology, we will use 2 reactors, not 5. We will use 2 reactors and we will get our desired amount of product. And we will have to maintain a temperature of 275 degrees Celsius along with a pressure of 0.75 torr. And it will be a 2-stage reaction. The reaction will carry on into 2 steps, and our raw materials in this case will be same as that one, like PTA and EG, purified terephthalic acid, and ethylene glycol. And our byproducts and product will be the same, water, oligomers, and our unsaturated polyester resin as the main product. Now talking about our third technology, the third technology is Invista NG3 technology. This is not most commonly used, but still gives us good results. And in this technology, we have to maintain a temperature of 300 degrees Celsius, which is a bit larger temperature as compared to other technologies, and a pressure of 25 psig, means 25 pounds per square inch gauge pressure. And this is also same as a 2-step reaction, and we will get same byproducts, water and oligomers, and our raw materials will be same, PTA and ethylene glycol. And in this technology, we have to use 2 reactors, which will be the CSTR reactors. And the volume of the CSTR reactors, how much we have to use the volume, how larger our reactor must be, it all depends upon how much production we have to do. And as we know, when we have to do a larger production, we have to use larger amount of raw materials, and depending upon their flow rates, how much of our raw material will get into the reactor, we will decide our not we will have to decide our CSTR or reactor volume. And if it's designing, we have to calculate it on the mathematical way, by engineering tools and engineering calculations. We have to calculate all the dimensions, all the volumes, and all the parameters of the reactor. That if we have a let's suppose we have thousand kilomole per hour of rate of reactant getting inside the reactor, then what will be our size of the reactor? We have to decide it, we have to calculate it mathematically, and then we have to apply some of the real-time calculations, and then we will decide the volume of our reactor.